Hello everyone, in this video we are trying to demonstrate how the Coriolis force works. We know that Coriolis force is an inertial force that acts on objects which are in motion related to a rotating reference frame. So in this video we are considering this carousel in the playground as a reference frame, and let's see what's happened. So we will try to see how the rotation of the earth influences the movement of the objects that are not connected to the surface, and also we will see how the Coriolis effect deflects the objects which are in the northern as well as in the southern hemisphere.
My name is Hamid. It's Thomas, and behind the camera is Neha. So we'll be demonstrating the Coriolis effect using this ball and this rotating frame.
So first we're going to show a non-rotating axis trajectory of a ball with no Coriolis force.
Yeah. Then we try to move. We try to project this on a rotating frame.
We're going to spin it.
We're gonna spin the rotating frame, so in order to capture the movements of the ball. So we try to see if this ball would deflect to the right or left when the rotation takes place. So I think that is what the demonstration is all about.
Yeah. Okay. Rotating. Hamid throws the ball and it goes straight. No deflection from side to side. Next.
The next is we try to rotate and see if there is any deflection from that non-rotating frame. So I think.
So from your perspective, we're going to rotate counterclockwise to simulate the northern hemisphere rotation.
Yeah.
And when Hamid comes around, he's going to throw the ball to me, and we'll see how that looks. We got to get him going real fast.
So in this non-rotating or inertial reference frame, we can see that the ball moves straight forward.
So next.
Now let's see what happens in the rotating non-inertial reference frame of the roundabout in the counterclockwise direction.
So now the Coriolis should show. So now the Coriolis should show. You want to show how it deflects to the right?
Alright. Then we try to.
So it is clearly visible that the ball deflects to the right of the source, and it's also seen that it makes a curve around.
And see if the ball will deflect to the left, right? Yeah. So
let's see what happens when the carousel is rotated in the clockwise direction, which represents the southern hemisphere. Here you can see that the ball deflects to the left side of the source and it makes a curve around. We can conclude by considering this experiment similar to that of the large air masses on the surface of the earth. So as the earth rotates, the spinning deflects air in a counterclockwise direction in the northern hemisphere, while it deflects in a clockwise direction in the southern hemisphere. And the deflection of the object due to Coriolis force is called the Coriolis effect and is caused by the rotation of the rotating object. French physicist Coriolis referred to this force as the compound centrifugal force, and later it was named Coriolis force. The most important impact of the Coriolis effect is in the large-scale dynamics of the ocean and in the atmosphere. The Coriolis effect of the Earth's rotation is greatest at the poles, and the amount of deflection decreases as the latitude decreases until it is zero at the equator. It deflects the surface currents just like it affects the wind.